Good evening, everyone. Today we're going to be talking about two different math problems based on the algebraic math system. We're going to be looking at the India algebraic system, and then we're going to be looking at the Islamic Arab algebraic math system. So basically, we're going to be looking at algebra, and we're going to be looking at two different problems that require different procedures, but they're very similar because they're based on Babylonian math. Some argue they don't really know if this system is based either on Babylonian or on Diophantus, but it's most likely that it is Babylonian. And we know that the Islamic Arab algebraic math system is based on Babylonian math, but it also has its roots in Greek math, because some of these problems that they use proofs to prove their algebraic math problems. So we're going to start off with the Indian algebraic system, and we're going to do number 15 from the book, chapter 6, and we're just going to solve 83x squared plus 1 equals y squared using Brahma-Gupta's procedure. Basically, what he does is he applies the method of composition to AB and AB, and then again he applies this method to AB and then to AB, comma b squared plus na squared, and then he comes up with the solution nx squared plus k equals y squared. And this equation gives him the solution of x and then y, and based on their system, k equals plus or minus 1, plus or minus 2, or plus minus 4. So what we're going to do is solve the system using the method of composition. So we have 83x squared plus 1 equals y squared, and we know that a equals 1, b equals 9, so we plug them into the equation. So it's 83 1 plus 1 equals 81, and in order to make it a true equation, we are going to include the negative 2 in the equation to make it true. So we know that x is equal to 2ab k, and then y is equal to b squared plus na squared divided by k. And so we're just going to substitute, and we know that is 2, 9, 1, and then k is going to be 2, and y is equal to 81 plus 83 times 1 divided by 2, and we get x is equal to 9 and y is equal to 82. So we found one solution to this equation, and we can find more solutions to this equation by using the method of composition. And in order to show that example, we will just say the next solution is equal to the composition of 982, which is equal to 2ab b squared plus na squared. And if we solve for that, we're gonna get 2 times 9 times 82, comma, and then 82 times 82 plus 83 times 81, which is equal to 1,476. 1,000. No, it's not 1,000. It's 11,476, and then 13,447. So we can keep on doing this method of composition, and we can get various solutions to this problem, and basically we just get the general case of x comma y for our equation. So that's this problem. We solved it using these equations that this mathematician came up with, Brahma-Gupta, and basically he uses quadratic equations, and he bases it off of that to solve these equations. He didn't really count negative numbers. He never really mentioned it in his work, but they usually just focus on the positive solutions. And also for this, we're going to move on to the Islamic algebraic math system, and it's also similar to the Indian algebraic math system, because they're also using quadratic equations and all of that, but they play around with these equations. Basically, Al-Khwarizm basically comes up with 6 cases for solving quadratic equations, and the reason why he comes up with 6 different equations is because he doesn't count the negative numbers for these solutions. So we'll just go ahead and apply this formula to find the solution of x for this problem, and we're going to use this formula right here to find the solution for this problem, because there are 2 different cases. For this one, we're trying to turn this equation into this format, into this formula, so we can solve for it. So the first step is just basically distribute, and then we solve it, and then we get our general case a, b, c. We get this formula, ax squared plus bx equals c. So we get it into the format of that equation. And then in order to solve it, we're just going to plug in the numbers to get x, and x is equal to 7 squared, 228, minus 7 squared, which is equal to 49 fourths, plus 9 12 over 4 minus 7 squared. If you just solve it out, then we get x equals 12. So that's our solution for this problem. And then similar thing goes for this problem. We're going to turn this equation into this format, ax squared plus c equals b of x. So we can then solve for x and use this formula. So the same thing again, we just expand it out and we solve for it. So we can turn it into the case ax squared plus c equals bx. Now that we have it in this format, we're going to use that equation to solve for x, and then x is equal to 10 over 2 plus or minus square root of 10 over 2 squared minus 21, and if we just simplify that, it's equal to 5 plus or minus 25 minus 21, which is equal to 5 plus or minus 2, basically tells us that x is equal to 7 or 3. So basically for this one, we get 2 solutions that are positive, and we get a positive solution. And these algebraic math systems are similar because they're using quadratic formulas, but they differ in the method that they're doing it. This is a little bit more simple. And then for this one, it's just a method of composition, of redoing it, repetition. So that's it for tonight. Thank you for watching.